Okay, here's example 2. It says, Gerline plans to attend university next year. Her grandfather wishes to deposit enough money today in an account paying 5.5% per annum compounded annually so that Gerline can make withdrawals of $5,000 each year for 4 years, beginning 1 year from now to pay for her tuition. How much should her grandfather invest today? Now, one of the things that might be a little bit tricky in this question is that it says 4 years beginning 1 year from now to pay for her tuition. And now, I know that seems kind of tricky, but all that really means is that this represents an ordinary annuity. So don't worry too much about some of the weird wording that you might see. All this indicates is that this is an ordinary annuity. That's all that indicates there. Now, is this a compound interest, present value, future value of an annuity, or present value of an annuity? Now, all of this depends on whether or not there are regular payments being made at regular intervals or regular withdrawals made at regular intervals, or if it's just a one-time deposit and then nobody touches the money from there. So, let's take a look. So, Gerline plans to attend university next year. Her grandfather wishes to deposit enough money today in an account paying 5.5% per annum compounded annually so that Gerline can make withdrawals of $5,000 each year for 4 years. Okay, so the fact that Gerline is going to be making withdrawals of $5,000 each year for the next 4 years indicates that this is an annuity. Okay, so she's making regular withdrawals at regular intervals. Every year she's going to withdraw $5,000. Now, is it present value or is it future value? Will she have the money right now and it's going to be invested so she can take it out in the future? Or is she putting in small bits of money now so that she has a large sum in the future? Well, if you read what it says about her grandfather, it says her grandfather wishes to deposit enough money today in an account so that she can make regular withdrawals of $5,000 each year. So what that means is she's going to have money put into the account. The grandfather's going to put in some money so that she can withdraw $5,000 each year for the next 4 years. Now, it's very tempting to just think, oh, well, why doesn't he just put $20,000 in and that's it? Well, that's because if he puts money in right now, then he can actually earn interest on that money so that by the end of the 4 years, the total amount of money that she withdraws ends up being $20,000. So, what does this mean? Because she's making regular withdrawals from an account and the money will be there right now, this is an example of a present value of an annuity. So, we're going to start with present value of an annuity. We're going to start with the present value of an annuity formula. And you get PV equals R times 1 minus 1 plus I to the exponent of negative n all over I. And so let's take a look at the information that we know. We know that the regular withdrawals that she's going to make are $5,000. I know the interest rate is 5.5%. And so this is 5.5% per annum compounded annually. This makes sense because interest is compounded on an annual basis and her withdrawals are on an annual basis as well. The compounding periods and the payment or withdrawal periods must be the same. So the interest is actually not going to change because it's happening on an annual basis. Okay, the number of withdrawals or the number of compounding periods. Because she is looking at withdrawing $5,000 each year for 4 years. What that means is she's making one withdrawal each year for 4 years, which is a total of 4 withdrawals. So if we plug in the information we know, one plus I would be 1.055 to the exponent negative 4. Remember, it's a negative exponent. All over 0.055. And again, because we have all the information on the right-hand side, we can type it all on the calculator and get our answer in one shot. So I get 5,000 times bracket, don't forget your brackets, 1 minus 1.055 to the exponent, negative 4, and bracket gives you the value of the entire bracket part here, divided by, so that's the same thing, multiplied by 5,000. So divided by 0.055, and I get $17,000 approximately $525.75. So what that means is, if the grandfather puts this much money into the account right now, she will be able to withdraw $5,000 each year for the next 4 years. Because what happens is, this is how much money he's putting in now. It's going to earn some interest in a year, and then she's going to take out $5,000. Then it's going to earn some more interest on whatever remains. Then she's going to take out another $5,000. Then it's going to earn some more interest on the 1 year that it remains in there. Then she's going to take out $5,000, and then by the end of the 4th year, she'll be able to take out another $5,000. So this is the total amount, or the present value of the annuity that the grandfather should invest today. So therefore, Gurleen's grandfather should invest about $17,525.75 today.